The switchboard manufacturer is required to comply with the requirements of the National Electrical Code, including Section 250.28d, which specifies the sizing of the main bonding jumper. UL has standards for the construction and testing of electrical equipment, but these standards do not supersede the requirements of the National Electrical Code. UL standards are used to ensure that equipment is safe and meets certain performance criteria, but they do not exempt manufacturers from compliance with the National Electrical Code. Section 250.28d requires the main bonding jumper to be sized according to Table 250.66, which is based on the size of the supply conductors. In this case, if the supply conductors are 1000 aluminum, this would require a main bonding jumper of at least 3/0 copper. The size of the cross bus is not directly related to the sizing of the main bonding jumper. The cross bus is used to provide a parallel path for current flow between the sections of the switchboard, while the main bonding jumper is used to bond the neutral and grounding terminals together. The switchboard manufacturer is required to comply with Section 250.28d and provide a main bonding jumper that is sized according to the supply conductors. In this specific scenario, a 1/0 copper main bonding jumper is insufficient, and the manufacturer should provide a larger main bonding jumper, such as a 3/0 copper main bonding jumper. To further elaborate on the requirements for main bonding jumpers, let's delve deeper into the specifics of National Electrical Code Section 250.28d and Table 250.66. Firstly, it's crucial to understand that the primary function of the main bonding jumper is to provide a low impedance path for fault current to return to the source. This ensures that overcurrent protective devices operate quickly and effectively, minimizing the potential for electrical shock and fire hazards. Secondly, the NEC provides clear guidelines for sizing the main bonding jumper based on the size of the service entrance conductors. Table 250.66 is the key resource for determining the appropriate size of the main bonding jumper. This table correlates the size of the service conductors to the minimum size of the bonding jumper, whether it's copper or aluminum. If the service entrance conductors are larger than 1100 copper or 1750 aluminum, a different calculation method is required. In these cases, the main bonding jumper must have an area not less than 12.5% of the area of the largest phase conductor. This requirement ensures that the bonding jumper can handle the potential fault current associated with larger service conductors. When dealing with multiple sets of service entrance conductors, the total combined area of all conductors must be considered when applying Table 250.66 or the 12.5% rule. It's also important to note that the main bonding jumper must be installed in a manner that ensures its mechanical and electrical integrity. It should be securely connected to both the neutral bus and the grounding bus in the service equipment. The connection should be made using approved methods, such as listed connectors or exothermic welding. UL standards play a crucial role in ensuring the safety and performance of electrical equipment. However, it's essential to recognize that UL listing is not a substitute for compliance with the NEC. UL standards primarily focus on product safety, while the NEC provides comprehensive requirements for the entire electrical installation. Manufacturers of electrical equipment are responsible for designing and constructing their products in accordance with UL standards. However, installers and inspectors are responsible for ensuring that the equipment is installed and used in compliance with the NEC. In situations where there may be conflicting requirements between UL standards and the NEC generally takes precedence. This is because the NEC is the widely adopted code for electrical safety in the United States, and it represents the consensus of experts in the electrical industry. Therefore, even if a piece of equipment is UL listed, it must still be installed and used in accordance with the NEC. When assessing the adequacy of a main bonding jumper, it's important to consider the specific characteristics of the electrical system. This includes the available fault current, the impedance of the grounding path, and the coordination of overcurrent protective devices. A properly sized main bonding jumper is essential for minimizing voltage drop during a fault condition and ensuring that overcurrent devices operate quickly and effectively. Inadequate bonding can lead to elevated touch voltages, equipment damage, and increased risk of electrical shock. The National Electrical Code is a living document that is updated every 3 years to reflect changes in technology and industry best practices. It's important for electrical professionals to stay up to date with the latest edition of the NEC and to understand how the code applies to their work. Continuing education courses, industry publications, and online resources can help electrical professionals stay informed about changes in the NEC and best practices for electrical safety. When working on electrical projects, it's always a good idea to consult with a qualified electrical engineer or inspector. These professionals can provide valuable guidance and ensure that the electrical installation meets all applicable codes and standards. They can also help identify potential hazards and recommend appropriate solutions. In addition to the main bonding jumper, other grounding and bonding components play a critical role in ensuring electrical safety. These components include the equipment grounding conductor, the grounding electrode conductor, and the grounding electrode system. The equipment grounding conductor provides a low impedance path for fault current to return to the source from electrical equipment. It's typically a wire or conduit that is connected to the metal enclosure of the equipment and to the grounding bus in the electrical panel. The grounding electrode conductor connects the grounding bus in the electrical panel to the grounding electrode system. The grounding electrode system provides a connection to the earth, which helps to stabilize the voltage of the electrical system and provide a path for lightning and other transient voltages to dissipate. The grounding electrode system typically consists of one or more grounding electrodes, such as ground rods, metal water pipes, or concrete encased electrodes. All of these components must be properly sized and installed to ensure that the electrical system is effectively grounded and bonded. Effective grounding and bonding are essential for protecting people and equipment from electrical hazards. By following the requirements of the National Electrical Code and best practices for electrical safety, electrical professionals can help ensure that electrical installations are safe and reliable. To further expand on this discussion, let's consider the specific context of the 480/277 volt Y system mentioned in the original prompt. In a 480/277 volt Y system, the neutral conductor is typically grounded at the service entrance. The main bonding jumper connects the neutral bus to the grounding bus, providing a path for fault current to return to the source. The 277 volts represents the voltage from each phase conductor to neutral, while the 480 volts represents the voltage between phase conductors. This type of system is commonly used in commercial and industrial buildings to supply power to lighting, HVAC equipment, and other loads. When working with 480/277 volt systems, it's important to be aware of the potential hazards associated with higher voltages. Proper personal protective equipment, such as insulated gloves and safety glasses, should always be worn when working on energized equipment. Lockout/tagout procedures should be followed to ensure that equipment is de-energized before any work is performed. The National Electrical Code provides specific requirements for working with 480/277 volt systems, including requirements for overcurrent protection, conductor sizing, and grounding and bonding. It's important to be familiar with these requirements and to follow them carefully to ensure electrical safety. In addition to the main bonding jumper, other bonding connections are important in a 480/277 volt system. These include bonding connections to metal conduits, cable trays, and other metal enclosures. These bonding connections help to create a low impedance path for fault current to return to the source and minimize the potential for voltage differences between metal parts. All bonding connections should be made using approved methods, such as listed connectors or exothermic welding. The connections should be tight and secure to ensure good electrical conductivity. Regular inspections should be performed to verify that all bonding connections are in good condition. Loose or corroded connections should be repaired or replaced promptly. Proper bonding is essential for preventing electrical shock hazards and ensuring the reliable operation of electrical equipment. In conclusion, the sizing and installation of the main bonding jumper are critical aspects of electrical safety. By following the requirements of the National Electrical Code and best practices for electrical safety, electrical professionals can help ensure that electrical installations are safe, reliable, and compliant with applicable codes and standards. Remember that the main bonding jumper size should be determined by referring to Table 250.66 in the National Electrical Code. This table provides the minimum size of the bonding jumper based on the size of the service entrance conductors. If the service entrance conductors are larger than the values listed in the table, the bonding jumper must be sized according to the 12.5% rule. Always consult the latest edition of the National Electrical Code for the most up-to-date requirements and guidance on electrical safety. In addition to the above, let's discuss some potential issues that might arise during an installation involving a main bonding jumper and how to address them. Firstly, there may be situations where the calculated size of the main bonding jumper results in a conductor that is larger than the available space in the equipment. In such cases, the NEC allows for the use of multiple smaller conductors, provided that the combined cross-sectional area of the conductors is equal to or greater than the calculated size. Secondly, there may be instances where the grounding electrode conductor is smaller than the main bonding jumper. In these situations, the grounding electrode conductor must be increased in size to match the size of the main bonding jumper. This requirement ensures that the grounding electrode conductor can effectively carry fault current to the grounding electrode system. Thirdly, it's important to ensure that the main bonding jumper is protected from physical damage. The conductor should be installed in a manner that minimizes the risk of abrasion, corrosion, or other forms of damage. If the conductor is exposed to physical damage, it should be protected by conduit or other suitable means. Fourthly, when making connections to the neutral bus and the grounding bus, it's important to use listed connectors that are specifically designed for the purpose. The connectors should be properly tightened to ensure a secure and reliable connection. The surfaces of the conductors and connectors should be clean and free from corrosion. Fifthly, regular inspections should be performed to verify that the main bonding jumper is in good condition and that all connections are tight and secure. Any signs of damage or corrosion should be addressed promptly. The main bonding jumper is a critical component of the electrical system, and its integrity must be maintained to ensure electrical safety. Finally, documentation is important. Keep records of the calculations used to determine the size of the main bonding jumper, as well as records of the installation and inspection. This documentation can be helpful for future reference and for demonstrating compliance with applicable codes and standards. Proper documentation is an essential part of any electrical installation. In summary, when dealing with main bonding jumpers, always refer to the National Electrical Code, follow best practices for electrical safety, and consult with qualified professionals when needed. By taking these steps, you can help ensure that electrical installations are safe, reliable, and compliant with applicable codes and standards.